exercise, we're going to take a straight length of copper wire, 12 gauge. We're going to bring the ends around and fit them together so perfectly that when they're soldered closed and the solder joints cleaned up, it won't be visible with the naked eye. For this, you're going to need a length of 12 gauge copper wire, small vise, flat file, or at least a hand file with a flat side, like a barrette file or a half round, bench plate, flush cutters, your combination pliers where it's flat on one side and round on the other. You may need a pair or two of parallel pliers, and we'll need a ring mandrel, a rawhide mallet, and for finishing the solder seam, you'll need your needle files, probably a half round needle file. Now, the first thing we're going to need to do is to figure out how long a length of wire we need to fit our finger. And there's two ways to go about that. There's a simple way and a little bit more tool-intensive way. Some of you may have used a set of these before at a jewelry store. This is a ring size set, and it allows you to figure out what size your finger is by poking your finger in the ring. And it's best to start with a ring size that you know is too big for your finger and work your way down so you don't end up getting stuck on your finger. And you work your way down through them until you find one, at least for me, that will tug at my knuckle skin, right? So that it doesn't just slide off easily. You want it to be a little snug. And then if you look at the side of the tab, there'll be a number, and if there's a minus side next to the number, that means and a half. Instead of putting the whole fraction in there, they just put a little dash and figured that people would figure out that that meant and a half. So 11 and a half fits my finger pretty well. On the flip side of it is sort of the metric equivalent. That's the diameter of your ring in millimeters. So with that number, right, that number doesn't tell us how long a piece of metal to cut. So with that number then, and with the thickness of our wire, right, which we know from earlier is 12 gauge, we can go to a chart where one side of the chart has your ring size, and the other side of the chart has the material thickness in gauge. And if you follow the two lines in the chart down, it gives you the length of wire that you need to make a ring that'll fit that size finger with that thickness of metal. So that's one way to do it. The other and less tool-intensive way to do it is to cut a strip of paper. And you don't want the strip of paper to be very wide unless the ring you're making is very wide. And if you're making a sheet band where that sheet may be covering up more of your finger and incorporating sort of more complex volume of your finger, then you want to make that piece of paper the same width as the band. But if you're making it out of wire and it's going to be fairly narrow, you want to cut a fairly narrow strip of paper. And you wrap it around your finger nice and tight where that ring is going to sit. And then mark where it overlaps. And then I'll usually tear off some of the excess paper so I don't get confused as to which end of that strip was my measurement. Right. And then to this measurement, you need to add in the thickness of the wire. So I'm just laying that on top of the strip and adding in the thickness of the wire. If you don't remember to add in the thickness of the wire, half of the thickness of the wire will end up inside your ring, half of it ends up outside your ring, and your ring will end up too small by half the thickness of the wire. And that doesn't seem like much, but that's multiplied all the way around the circumference of the ring. So it'll end up significantly too small. All right. And I've compared this method to the chart method before, and they come out almost exactly the same. Okay, so the next thing I need to do is to cut a length of wire to fit that template, or I can, if I've used the method with the chart and the ring size set, I can measure that out using a ruler. But for this method, I'm just going to lay my paper up against it like it's a ruler. Now, the first thing I'm going to do is this wire's been cut off with a either the back side of the flush cutters or a diagonal cutter. So the ends are really pointy and munchy. I'm going to trim that off so I've got a nice flat end to start with to measure from. I'm going to lay my wire across that. It's easier to do if you can lay it down against the table. In fact, I would probably sort of rough cut the wire so you're not having to deal with that whole coil. So I'm going to lay my wire down on the template and cut it. First I'm going to take that clipped end off of the wire so I have a nice flat end to measure from. I'm doing this with the flat end or the flat side of the clippers toward the body of the wire. And then laying it on my template. And I'm going to leave just about 1 millimeter at each end hanging over. And grab it with the clippers where I'm going to cut it. And then clip it. Clip that end off. So it's just a little bit longer than my template, because I'm going to do a little filing on those ends. So I need just a little bit of extra. According to Wikipedia, capillary action is the ability of a liquid to flow in narrow spaces without the assistance of, or even in opposition to, external forces like gravity. It occurs because of intermolecular forces between the liquid and surrounding solid surfaces. If the diameter of the tube is sufficiently small, then the combination of surface tension and adhesive forces between the liquid and the container wall act to propel the liquid. What this means for us is that if we get a good enough fit between the parts of our seam, the molten solder will be pulled through to the other side. Now that's still going to leave some pretty pinched ends to your wire, and if we leave those when we go to solder this thing together, those ends will be pushed apart by that little texture that's on the end of the wire. We need to file that perfectly flush and flat so that the ends of that wire are as clean and smooth as possible so we can get a better fit between the ends. The easiest way to do that, I've found, is to put the wire in one of our small tabletop vices and leave just the end of it sticking out, just that little millimeter extra that we left in the length of our wire sticking out past the surface of the vise. So that's just barely sticking up above that surface. And then file all the way down to the surface of the vise. You're basically using the vise as if it was a straight edge, like if you were cutting using a straight edge and an X-Acto knife. I'm using the surface of that vise to keep from filing at an angle or to keep from filing too much material away. And I'm just keeping going until that little nub of metal is flush with the surface of the vise. And you'll be able to tell when it's flush because at first there'll be a resistance as you're cutting away that copper. And then as it hits the surface of the vise, the file doesn't really work well on the surface of a piece of metal, so it'll just start to skid. All right, and you'll know that you're all the way down to the surface. All right, so I flip it over and I push it back the other way, leaving just that extra little millimeter that we left on the other end sticking out. And I file that nice and flush with the surface of the vise. After filing, the end of the wire should be perfectly flat and perpendicular to the sides of the wire and should have nice crisp corners. The end of the wire is going to have a burr from all that heavy filing we did. To get rid of the burr without beveling the ends of the wire, you're going to lay it flat against the file and just turn the wire as you pull it across the file you don't want to put a new edge on that end of that wire. You just want to take the burr off. The next thing it would be good to do is to anneal your wire so it's nice and soft and easy to bend before you go on to the next step of bending the ends together. So our wire's softened up, it's annealed, it's pickled, it's ready to bend. And at this point, the only thing that matters is to get those two ends flat up against each other. It doesn't matter what shape my ring is going to be, all that matters is I get these two ends together. And I usually find that the easiest thing to do is to make a triangle with the two ends in the middle of one of the sides. So I'm going to start by grabbing it with the combination pliers just to one side of center, and I'm just pushing the ends up to make a V shape, right? With a nice soft curve at the bottom. You get that soft curve by going as far in toward the hinge of the pliers as you can. I'm going to come out here about 2/3 of the way toward the end, and I'm going to bend the ends back toward the middle, right, to get a nice soft cornered triangle. Now at this point I've got this big space here, right? That's no good because that's going to keep my ends apart. I'm never going to be able to make a solder joint with that. But I can get rid of that just by pushing those ends toward each other, right? Because you can see that they're not really pointed right at each other, they're pointed more toward the center. So I'm going to bring them out from the center a little bit before I do that. Right, so they're pointed more at each other. And if your metal's nice and soft, you should be able to do a lot of this with your fingers. The more you can do with your fingers and the less with the pliers, the less chances there are for you to push the metal of the pliers into your metal and make a dent, right? Put tool marks, plier marks in there. So now that that gap is a little closer and those lines are pointed straight at each other, I'm going to try to close up that gap, and you can see that that gap just keeps wanting to reopen. So what I have to do is push the two ends off axis with each other, push them past each other. So now the elasticity of the metal wants to pull those ends together, and then pull it back just until those ends will pass. Bring it back, and then let it snap back to center. As you know from the bending demo, every time you're trying to make a permanent bend, you have to flex the metal past what you want, let it spring back to what you want. Right. And I can tell if I'm lined up by running my finger across that end. If I'm feeling an edge, I know it's sticking out. So like when I run my finger over this, I can feel that there's an edge sticking up here, and I know that my ends aren't really lined up very well. I've got one side that's more toward the middle, so I'm just going to bring it further out. And then run my finger over there again to see if they're lined up with each other. Right. Now, this looks pretty good right now. Right, to my naked eye and to my fingers, it feels like that gap is closed. It feels like the ends are lined up. But that's not really good enough for soldering yet. What I need to be able to do is put on my visor and look through that gap, held it up to the light, and look through that gap between those ends, and I should be able to not see any light, or I shouldn't be able to see any light coming through that seam. No matter how I turn it, no matter how I twist it, I shouldn't be able to see any light coming through that seam. And if you're using your visor and you've got some good light behind it, the light that you're seeing through there will most likely be wedge-shaped because that gap won't be even. It'll be, like one edge touching and the other edge still open, right? And that wedge shape of light will show you which direction you need to correct in. And at this point, when you're holding it up against the light, if you can't see a gap with the naked eye, if you can't feel a gap with your fingers, can't feel those edges sticking up with your fingers, any corrections you're going to be making are going to be very slight, right? So like if if I've got a little wedge shape of light showing from this side, all I'm going to do is put my fingernails to one side and just flex it in the other direction. Don't think of it as you're bending it, because then you'll overcorrect. If it's on this side where my thumbnail is, then I'm going to put my thumbnails against there and I'm going to flex it away from the wide end of the wedge. Same thing with if you're seeing a wedge from the inside or the outside. You're just going to flex those ends either more toward the middle or out away from the middle. But you're just, again, if you can't see it with the naked eye, if you can only see it with your visor, just think of it as you're flexing the material and letting it come back to the middle. While you're doing that, while you're making those corrections too, be very gentle with the metal. You never really need to squeeze down on the pliers. If you squeeze the pliers, you'll pinch little dimples into your metal that you'll end up having to file out, and then you'll have a visible thinness in the parent material after the fact. Also, you never want to pinch right up near the seam, because the metal will collapse at the end, and then you'll never get rid of that gap in between the two ends. Right? When you spent some time getting those ends nice and flat, you don't want to ruin that by crushing the ends so that they're no longer flat. If you're making a correction in or out from center, use your combination pliers with the flat side out. Right? And again, just gently pull it out from the center or push it more toward the center. If you're making a correction this way, either use your fingers so that you're not dinging up the material, or use parallel pliers, because when they grip, they distribute the force of that grip out over more material, and that way you can get more leverage, a better grip, without risking damage to the material. Especially if you're working with thicker material, stiffer material, you're going to need the extra leverage of some parallel pliers. But don't try to do this with single joint pliers, because you'll just end up dinging up the metal and you'll have a lot of file marks you have to scrape out of there. No matter how good the fit between your parts, if your metal is dirty, the solder won't flow. So the first thing you'll need to do is to drop the piece into the pickle to get rid of the oxides that are already on the metal. And once the pickle's done its job, scrub the piece with a brass brush and some soap to get any kind of tool or finger grease off of the piece. If your metal is dirty, when the solder liquefies, it can't flow. And as soon as you start taking a torch to metals such as copper, it immediately starts to oxidize. So we'll need a barrier of some kind to keep the metal from oxidizing while taking a torch to it. And the way that we do this in soldering is use a chemical flux. The flux sits on the surface of your metal and gobbles up the oxygen that's trying to get to the surface. And it does this at room temperature if it's exposed to air, but as you heat it with the torch, it works faster and faster, gobbling up more and more oxygen. But it eventually gets to the point where it can't absorb any more oxygen, and it burns up and becomes dirt. So you're in a race with your heating to bring the piece up to the point where it will melt the solder before the flux burns up. Now our flux is a suspension, which means it's a solid that's mixed with water, but it doesn't dissolve into the water. It just kind of gets mixed up, and then it'll eventually settle out over time. So the first thing you need to do is mix it up really well with a spoon. And if it's become too thick, water it down a little bit until it's the consistency of heavy cream. Then using a small paintbrush, you want to apply a layer of flux to the joint and the surrounding area that is good rich flux, meaning it's got a lot of solids in it without a tremendous amount of liquid. But you don't want this layer to be terribly thick. Otherwise, when the solids melt, sometimes your solder pills will actually float away on it. Make sure when you're done, you close the jar and rinse out your brush.
Otherwise, the flux will be exposed to air and will use all of its capacity for absorbing oxygen, just eating up the room's air. Next, we need to put our solder pills or palins in place. And these should be cut as small as you can make them, usually only about as long as the wire is thick. And this is easiest to do with your flush cutters, just clipping the pieces into your palm. You'll only need one for the ring exercise, but it's good to always cut more than you need and have a few extras handy in case one falls off your piece. You don't want to have to scramble in the middle of soldering something to cut more. Use a pair of stainless steel soldering tweezers to place one of these pills right on the seam. It will only get pulled into the joint by capillary action if the pill is actually touching both edges that are being soldered together. This may take a little bit of time to get the pill into position. The flux, if it's still moist, acts as a sort of bonding agent to hold the solder pill in place. And if it's dried out a little bit, you may have to add a little bit of a drop of water to it using the tweezers. Take your time and make sure that the pill is right on the seam.